Hello everyone, in this video we'll be solving a simple problem from the design of semi-elliptical leaf springs. So here you can see this problem. Here we have to design a truck spring. That means we have to find the dimensions which is having 12 number of leaves. That is the total number of leaves, 2 of which are full length. We already seen in last video what are full length leaves and what are graduated. And so remaining 12 minus 2, remaining 10 number of leaves will be graduated, which is including the master leaves. So the spring supports are 1 meter apart and the central band is 70 mm. So this information will be used to find the effective length, that is L. And the central load is to be 6 kilonewton, that is the value of F. So already I have mentioned the correction to be made in the figure and data book. Whatever be the central force acting or the central load on this leaf spring, that should be taken as F. And permissible stress of 200 megapascal, that is the maximum normal stress, allowable normal stress to be used in design is 200 megapascal. Here we have to find the thickness, width and deflection of this spring. Thickness means B dash we have to find, thickness means H we have to find, width means B dash we have to find, and deflection Y of the spring we have to evaluate. And one more information is given at last, if the ratio of total depth to width of the spring is 3. So we will be seeing what is actually this one. So total depth means if you are seeing, so this much will be the total depth. So this total depth will be equal to, since each leaf is of a width h, and if I is the total number of leaves, then I into h will be the total depth. So this is equal to the total depth, and it is given the ratio of total depth to width of the spring. Width of the spring we are using the letter B dash, and this information is given equal to 3. And here we will be counting the number of leaves. So total number of leaves I equal to 12, and out of which full length, that is IF is equal to 2, then the IG value will be equal to 10. So these are the number of leaves, and here you can substitute this I value is 4. So 4h, I value is 12, total number of 12 leaves, 12h divided by B dash will be equal to 3. And from this one you will be getting B dash will be equal to 4 times h. So this conclusion you will be getting. Next you will be finding the value of this B dash h. For that, the permissible stress value of 200 megapascal will be using. So we know that whenever this leaf spring is subjected to the central load F, so we'll be taking this F, and the value of F is given. So the F is equal to 6 kilonewton, or 6 into 10 raised to 3 Newton to be substituted. And whenever this load is acting, the stress induced in the full length and graduated leaves are different, because here the effect of pre-stressing or nipping is not mentioned. So we'll be taking as usual. So the stress induced in the full length leaves is given by this expression, sigma f equal to 9fl divided by that quantity, and the stress induced in graduated is sigma g equal to 6fl. So already we are knowing the full length stress induced in full length is 3 by 2 times, that is 9 by 6 of sigma g. So this quantity is the maximum. So this one sigma f should be used for design. So with this one you will be designing and find the dimensions. So designing means this sigma f will be, maximum stress will be equated to the allowable strength of the material, and from that we will be finding the dimensions. So here we will be making use of this expression to design this leaf springs by equating this maximum stress induced in full length leaves to this allowable strength of the material given. So for substituting in this, we will be requiring L, where L is the effective length between the I, where this supports are coming, and this central band, where this bolt are coming, which are used to bound this. And here it is said that the supports are 1 meter apart. That means this distance is 1 meter. So the center of this leaf spring, that means this position where load is acting up to this I will be 0.5 meter. And you are having the central band, that is the distance over the U bolts that are connecting the spring is 0.07 meter or 70 mm. So from this you can find this effective length. That means this distance as 0.5 meter minus 0.07 by 2. Then you will be getting 0.465 meter or 465 mm. So this expression you will be using in this one. And then you can substitute all these values. So this is 9 into F is 6 kilonewton, 6 into 10 raised to 3 into L is 0.465 divided by. So now we have already evaluated b dash in terms of h. We have evaluated previously b dash equal to 4h. So this you will be getting 4h into h square, 4h cube into 2 into ig is equal to 10 plus full length leaves is 2, and this will be equated to the allowable strength, which is 200 megapascal. So you will be getting 200 into 10 raised to 6. So only unknown is h. So if you are solving this one, you will be getting h in meters. The value you are getting is 0.01065 meter, and this is equivalent to 10.65 mm, and you will be standardizing this one, and the standardized value of this h you will be taking the next even number, that is 12 mm will be the standardized value. That is b is actually the thickness of the spring. So once you are having this h value, you can evaluate the width of the spring, that is b dash. We are already knowing the expression b dash is 4 times h, then this will be getting b dash will be equal to 48 mm. So this is the value of b dash. So now we have evaluated the dimensions, that is width of the spring as well as the height of the spring we have evaluated. Next, in the question it is asked to find the deflection of the spring. So in last step we will be finding the deflection of the spring also. So for finding the deflection of the spring, we will be making use of this equation. This equation is given in this here, the 11.31c. And so you can substitute all the values in this SI unit. So F is 6 into 10 raised to 3 Newton. This L is 0.465 meter. You are having this B dash, which is 48 mm or 0.048, and this H value you are having 12 mm, which is 0.012 meters, and Young's modulus of the material is I think it is not given in the question, so you can take a value of 200 gigapascal. So it is 200 into 10 raised to 9. So number of graduated leaves is 10 and number of full length leaves is 2. So now you can substitute all these things and define the value of this deflection in meters you will be getting, since you are using SI unit, and then that value will be equal to 0.00806 meter, and this is equivalent to 8.06 mm you will be getting. So this is the deflection that has occurred for this leaf spring. So this is the complete solution for this simple problem. So hope you understood, and thanks for watching.